Like yesterday, we were talking about this pipeline, right? Of course, a very big picture, a high level picture of CI/CD pipeline, wherein I was talking about there were so many tools involved. We'll be zooming into each tool in detail. We'll expertise each tool and build this pipeline step by step. So let's begin with the same. Today, we'll be starting with the first tool in our CI/CD pipeline, which is Git. Right? Please keep muted, everyone, unless you have a question. If you have a question, you can unmute and speak out. Otherwise, please keep muted so that we'll not have any background noise. So let's get started with the Git. What is a version control system? What is a Git and all? So what is a version control system? Some of you might be aware of it, some of you might be using it, you might be using different version control systems. So I would like to hear from you, or else any idea you have. What do you think it is? Anything you know about this? What is a version control system? Anyone?
I mean, to track the number of the changes performed by the developers.
Only developers? Who should use it?
Yeah,
Tracks the changes of only developers, or which kind of changes, what it will track?
those who are performing continuous changes, they can maintain their versions for the recovery purpose.
Okay, anyone using any version control system? How many of you are using it or used in the past? Like
I have used
which tool?
SVN repository. I have used.
Mm-hmm. Okay, Bhaskar have used it. Which tool you have used, Bhaskar?
Uh, Even we use it Git sometimes, and then laid back in few other tools like
Okay,
what you call Visible
fine.
SEM,
Hmm.
and there is a couple of other tools actually. I
All
didn't.
right, no problem. So, yeah, some of you know or used version control systems, and how many of you are new? New to any version control system? Can I consider them as majority?
Yes.
All right. So yeah, anyway, let's begin. Let's see what is a version control system initially. So to understand the concept of version control system, let me take a simple example. Let's suppose there is a project. Okay, people are working on this project. This is a project like this is a shared folder. Let's say they were working on a project and this was a shared folder for that project. There were so many files kept in this shared folder, shared drive, shared across all the team members. There were so many files again, subfolders. All the team were using it, right? Let's suppose there were two persons in the team. Let's say a person A, he could be a developer, he could be a tester. You may consider them as developers or testers or DevOps team, right? Whoever it is. So there were two people who are working on this project. And here on this remote shared folder, this is, I'm talking about without version control system. There is a file called file1 on this remote, right? So now this person A want to make changes on this file1. So he got this file into his local computer, means he downloaded this. Similarly, B also downloaded at the same time. Both of them need to make some changes there. So both of them downloaded the file at the same time. And then A made some changes to this file. A made some changes to this file. Also, B also made some changes to this file. Okay, and then A put this file back. A kept his file back. B also kept the file back. But let's say A kept the file on day one, or else let's say uh, uh, today, right? He will keep this file, or else he kept this file on Monday. Then B kept the file back on Tuesday. Let's say this happened last week. So B pushed his changes, kept his file back on Tuesday. Now tell me, like after Tuesday, after both of them have pushed the changes, this file on remote, file one, will have which person changes? Will it have both the person changes?
B1 only.
The
Only
latest
B
one.
person changes, right? Means whoever pushed at the last, right? Because what is happening here? Person A changes are being overwritten by person B changes. Why is this overwriting happening? Did B ask to do that? Right? It is happening because simple logic. A kept the file with his changes. Then B kept the file with his changes. But B, when he's keeping the file doesn't have age changes, right? Simple logic. Without using any version control system, this is what going to happen. Person A's changes are being overwritten by person B. Person B doesn't know this. Even person A don't know that his changes are being overwritten, right? So this is what is happening. Let's suppose these are developers, right? These are their program files, so they were making changes. Or else consider them as testers. Those are their automation test cases, right? When you are going for automation testing, even testers do write the code, test scripts in some language, like says if they're using Selenium or UFT, whatever. So automation test cases might be there, whatever it is, or else it might be a DevOps person, right? It might be some configuration file. So whatever it is, so one person changes are being overwritten by other. See, A have to concentrate on his requirement, his task. He cannot just go and see whether his changes were stored properly or someone else is overwriting him. He can't do that manually. Keep on doing it manually, continuously, right? So that's where comes a system in need which can handle this. Means we need a system which can allow multiple people working on the same files or same code. It should allow people working on the same file simultaneously without overriding. Allow people to work simultaneously on the same file, right? So how it works means there should be a system which should handle this, which should not override the other person changes, which should have good track of the changes, right? That's one thing. And let's suppose, okay, till today application was working fine till 7 o'clock or else till 5 o'clock. Something happened at 5:30 and application got crashed. Business went down. We need to put the system back again. Immediately, I need to remove the changes which were done between 5 to 5:30, right? How do I know what changes happened, who made changes to which files at what time? How do I know? So even I need a system which can have a detailed logging, right? Means a system which can provide a log in such a way that yes, person A made changes to file 1 on line number 9 at 5:15 a.m. This kind of detailed logging, including the timestamp, including the file name, what change he made. If we have this kind of logging, yes, we would revert, we would undo those changes so that the system can be back. We can see that business doesn't go down, right? Got it, all of you? So this is another thing like we can handle, like we need a system which can do this. Not only this, let's suppose, okay, client came and said they need some changes to this version 1. So I modified this file 1 and made version 2. Okay, so now version 2 is being used. But then client, after a couple of days, this version 2 is not working properly. Like it was not meeting their requirements and it causing some other additional problem. So they just want to go back to the previous version, like file 1 version 2. They want to just go back to the older version. But I have overwritten it. I have edited the same version and made it. So if I need version 1, a lot of rework, right? So how to avoid this? Don't ever overwrite the files, edit the files, make a new version. Maintain the backups, maintain the versions, right? You might have maintained that version, maintain file 1, version 1. Also then make a version 2, right? So maintain the versions, right? Means maintain the backups. Even we can't do this manually. We need a system which can handle this, right? We need a system which can take care of the system not to override the changes of others, which will help us in logging, which will help us take backups. All of this should be handled, right? That's where comes a versions control system into picture. So means whatever files you have, all of those can be version control. Version controlling means it helps you to provide logging, it helps you to provide backups, maintain versions, it helps people to work simultaneously on the same file at the same time, because that may be the scenario in the real practice. Many times that happens because it's a team of people who are working. This basically helps you to have better collaboration across the team itself, right? So this is what is version control system. So only developers should use it. Everyone or anyone can use it who want to maintain their files. It might be program files, It might be configuration files, it might be some test scripts, whatever it is. Any static files can be version control. Even for your personal purpose, you can use it if you have some documents and all, if you want to save them, maintain them properly, if you have some technical skills, right? So basically, okay, now in IT, who will use it? Definitely developers, mandatory for them. They'll be using it. Of course, testers are also using it nowadays because they do automation testing. They have a lot of test scripts. DevOps persons also use it to version control their files because yeah, they'll be having some configuration management files, script files, right? We are managing our infra with code. All those files should be version controlled. So everyone in IT should learn this version control system. This is with respect to managing your files. First, as a DevOps person, you should also learn it. Next, second perspective of learning it is, we will be using it in the CI/CD pipeline. Like whenever developer make changes to his code, to his files, it should trigger the pipeline, right? We will integrate this Git in our pipeline. So for that from that perspective as well, we need to learn Git. So first we learn from the perspective of version controlling the files. Means how do you version control your files? How do you maintain backup? How do you do logging? All of this we learn. Then we will learn about integrating it in the pipeline. So I believe now you could answer what is a version control system, why you should use it, as a DevOps person, why you should learn it. Are you clear with these questions? Any confusions, any other doubts in this part?
Yeah, Preeti, I have a question. See, actually, I never used any of the version control system, but I have seen a few of my colleagues used it in SVN. So whenever they are checking out any of the file to update something, it it got locked and it is not allowing others to check out or to do the modification, right? If that is the case, we can't update the same file simultaneously, right?
That's what it is not. That's what it will take care of one person not overwriting the file. You can download it locally and make the changes, but you can't put them back. That's what is locking. Here in Git also we have that, but it does in a different way. We will learn about it. That's a mechanism it's using so that it will stop people overwriting the changes of others. Still, you can make changes, but you can't put them back until others unlock it.
Pretty, I have one question.
We will
Like,
learn those, one second, we will learn those scenarios, okay? We just started with it, we'll get into those scenarios. Yes, tell
Huh.
me.
yes. So let's say, for example, in my organization, we are using Excel files for leave tracking purpose. Okay.
Hmm.
Now it is hosted on Google Cloud.
Hmm.
Okay? And all the people have access to it, and they are all making changes simultaneously, like whosoever is going to update it and all the changes are saved. So just like you explained that there is a login system in version control. Actually, it is not there. So what is the other difference between those, I mean, cloud documents and the files that we are maintaining on version control?
Cloud document is like a shared file,
Like
right? A
Google
shared
Docs,
folder.
you
Hmm.
understand Google Docs, right?
Yes, yes.
Yes,
It's
yes.
just a shared folder. Your version control system has much more beyond that. Like it will maintain the version. You can retrieve any version at any point of time. Can you do that in your Google Docs and all?
No, no,
You
no.
can retrieve a particular version, right? People can push their changes parallelly. When something is a conflict or overwritten, it will show you the merge conflicts. It's way beyond that, right? You have a
Yes,
logging as well. You don't have all these features, right? Very obviously.
yes,
You
yes.
know which person made changes on what line at what time. For those kind of data, we don't need this version control system. But for our configuration files, but for program files which developers write, that's where we need all of this, right? Versions, logging, merge conflicts when some person is overwriting the changes of others, right? We have also branching feature. Many other features are in Git
Correct.
beyond just a shared drive.
Yes, yes.
You can revert, reset, so many things are there. Okay, we'll go through all of them one by one. But
Okay.
yeah, so just here itself, it clearly shows the differences between a shared drive and the version control system.
Yes, got it.
So yeah, this is what a version control system does. So everyone should learn it. You can learn this with any file. For now, initially we did not start writing any configuration files and all. So we'll be using some text files or whatever files you want, you can use it. But the concept is all of these features we'll learn in version control system. Now, these version control systems, based on their architecture, were categorized into two types: centralized version control system and distributed version control systems. So, what are centralized version control system and what is distributed? Like I said, based on their architecture. First, let's see the centralized one. See here, there is a repository or else a central repository or remote repository, whatever you call it. This is on some remote location, right? So whoever want to work on it, let's say you are talking about developers team, then developer one, or else a DevOps team, let's say DevOps person one, two, three, they will just connect to this remote repository, get their local copy, means get the copy of that remote repository into their system, into their local machine, make the changes there and put the changes back, right? They'll pull the changes and put the changes back, right? This is how a central version control system works, a simple architecture, but there are limitations or drawbacks with this kind of architecture. First thing is you need always network connectivity to work on this remote, because you have to get the changes, make the changes and put the changes back, right? Always network connectivity is required. If you don't have network connectivity, yes, your entire work is halted, right? So this is one drawback. And the second drawback being, um, like let's suppose this central server got crashed for some reasons, right? For some reasons, this got crashed. Chances of recovery are less because it works like single source of truth, right? Chances of recovery are also very less. Yeah. And then the third thing, because you need to connect your remote server through network and all, definitely like when you're working on it, the changes, pushing the changes or getting the changes, it will take some time. We can say it is slow when compared with the distributed version control systems. So these are the limitations or challenges we have with this kind of system. So how to overcome these challenges and what are the version control system which comes under this architecture? SVN, TFS, Perforce, all these tools comes under centralized version control system architecture.
VSS, WinCVS.
Yes, all of these comes under central version control system only,
Yeah.
centralized. And then to overcome these drawbacks, we have got the distributed architecture, right? If you see here, there is again a remote server or central server, right? And then this is the workstation of each individual user, right? They'll connect to the remote repository. This is the laptop of each individual user, workstation, whatever you call it, right? This is their local machine. Now, this is the remote or central server. Here in this distributed architecture, we'll have two repositories, remote repository or central server, and then the local repository. Means every user will have a copy of this remote on his local, right? And he will again not make changes directly here, but he'll make changes in this another folder, which is called as working copy or working directory. They make changes here, right? They keep modifying changes here, and then they push the changes to local. From local to remote. It's not directly from working directory to remote. No, this is not possible, right? Only from working directory to local, from local to remote, right? So this is the distributed architecture. And what is the advantage or how it overcomes the drawbacks of remote? Yes, it can overcome the challenges of remote repository, centralized version control systems, because see, everyone is having their own copy. Even though network is disconnected, still they can make changes to their code or their files, right? Because they have a copy of a local. But to push and pull, you need network connectivity for sure. Means to move your changes to remote, right? Or to download the changes from remote, you need network connectivity. But these pull and push are less frequent because see, once everything is ready, then only we move them to remote, right? So these are less frequent. Most of the times we work on local repository. Once complete work is done, then only we push. So even though network is not there, like network disconnected, you can still work on your local. Entire work is not halted, right? That's the second thing. Next thing is, because majority of the work is happening on local, we can expect like, yeah, it is a bit faster. Only once you have to push, like once everything is done, you'll push, right? So it is also faster. Also, let's say the central server got crashed. Chance of recovery are more because everyone is having a copy of remote. So chance of recovery are far better, right? So that's how it overcomes the challenges posed by centralized version control system. And this is the distributed version control system, and this is being used in modern DevOps projects. And yes, Git falls under this distributed version control system. Git, Mercurial, Fossils, these comes under distributed version control systems. Out of all, Git is again very widely used. Git is very famous because of its many other features, like it has got a robust branching feature. We'll talk about them as we progress. So yeah, this is very widely used. Majority of the projects are using it, particularly for DevOps. So this is the kind of architecture it implements. And yeah, see here, like I said, push and pull are less frequent. Unless you push your changes remote, others can't see them. If let's say those changes are in your working copy or else in your local repository, no one else can see them unless you push them to remote. Only once you push your changes remote, others can see them. Got it clear?
Yeah, one quick question here.
Hmm?
Here, centralized version controller, while see if you're opening a single file with multiple users, is it possible?
See, this is confined for a single user. This local repository is, let's say, my
I
repository,
want to
developer one.
understand, like centralized version controller, right? So that was shared drive, which
Hmm.
we do over the
Yeah,
network.
here multiple people will be working. That's why, see, everything is connected here. This local is
No,
confined to user one.
in centralized version controller, one file can be opened with many users, or it will be
Yes.
locked.
They can open it, they can edit it, but they cannot put it back. When they are putting it back, it will be locked. Unless the previous person unlocked it, they cannot put it back to avoid the conflicts, to avoid the overwriting.
Okay, okay.
Here
No,
also,
no,
there is a mechanism. Just 1 second, please. Here also there is a mechanism which will not override the changes of others. That's where it happens to merge conflicts. We'll execute those scenarios. Okay, we'll do hands-on on those one by one.
okay.
Yes, please go ahead. Some
Yeah,
of
this pull and push is manual, right? The way it's automated.
Yes, pull and push are manual. If you want, you can automate it. That's not a big deal. Just with a simple scripts and all, you can automate. But pull and push should be manual because consciously, as a developer or DevOps person, you make changes and you know when to push or when to pull, right? But when you are running CI/CD pipeline, we have to pull the code. Means the system has to pull the code whenever developer make changes. Then build it, test it. Then we will automate the pull. Automate the pull in the sense whenever they pull, then we'll automate the next task. Pull will not be automated actually, but can be automated. Got the point?
Yeah.
Priti, in this distributed version control system, the main repository that you are mentioning, is it further divided into some local repository also for particular users?
No, that's a remote repository, only one single repository where all these users D1, D2, D3 can connect to it. Everyone will have access to it. Of course, again, their access levels could be different. That's a different part. But yeah, all of them will be connecting to the remote repository.
Okay.
So one quick question. In a centralized repository, we do have a local repository also. We also clone that the remote repository, right?
We don't clone there completely. We get the files whichever we want to make changes. It will not be a complete copy of remote.
Okay, so we get only those in which we want to be changes, right?
Mhm.
And we'll do changes and we'll do push the remote.
Yes.
But in distributed, we totally clone that repository and do the
Yeah.
Will the changes will
You
be?
can get a complete copy.
Okay.
Any more questions? See, if you know one version control system, other version control systems will be almost similar, right? The terminology may be different, but the concepts would be similar. So mastering one tool in each category is great, and that's more than enough. Like you have push-pull here in SPN, you have check-in and check-out. The terminology will be different, that's all. With just little exploration, different little research, you can just switch over to any other tool. So this is about the distributed version control systems. And now that we understood the architecture of them, now let's talk about, okay, before going to Git, see here the comparison of different version control systems, right? Of course, there's a graph from Google Trends graph from 2020. You can also get the latest graph. Git is clearly the winner in the category. Can you see the blue one is for Git, right? Other tools, like there were no good competitor for it. And now let's talk about the architecture of Git in particular. We have discussed about the architecture of distributed version control systems in general. Now look at this architecture in particular. See here, like we discussed, yes, this is the local version controls, sorry, local repository, and this is the remote repository, right? So now how do you, like, let's assume this is a remote and this is your local, like there's a workstation of some individual user. Here, let me talk about few things. How do you create a local repository, right? There could be different scenarios or use cases. Let me talk about the first one. See, suppose there is a project already, a 3-year-old project. I joined the team today, like as a new DevOps person. Now I want to make some changes to the existing configurations. So because it was an old project, it was a 3-year-old project, there's already a lot of changes, lot of configuration files were there on remote. So I will copy from the remote and create a local repository in my laptop, correct, in my local machine. So this is one way to create a local repository, one use case. Second use case could be, let's say there's a new project, okay, they were forming a DevOps team so that they want to automate the infrastructure and all. So it was a new DevOps team. There's nothing on remote, no code, nothing on remote. So here you can create a local repository manually, right? Create a local repository manually, an empty local repository, develop it, then push back to remote, right? You can also create an empty local repository manually, develop the code or develop the files. Code in the sense it's not only for developers, like develop the changes, develop the scripts, then push to remote. So local repository can be created in two ways. One second. So let's suppose, okay, we have created the local repository. Okay, and let's assume, okay, we are following the second use case. Let's say it's a new project, there's nothing on remote. I have created the local repository manually. How to do that, I'll show you. Okay, we are going to go to the hands-on in some 5 to 10 minutes. So yes, let's assume, okay, I have created local repository. Local, it's nothing but a folder. Okay, in your system, it will be a folder. If you are a Windows person, it's a folder, or if you're a Linux guy, consider it like a directory. Okay, fine, I have created an empty local repository. Now I have to make changes here. Again, you will not make changes here directly. Like I mentioned some time back, you will be making changes in another directory called working directory. Okay, it's called another folder or another directory where you make your actual changes. Here, actually, you make the changes. Then again, it's not that from working directory, you can't directly push to local. There is another layer in between called as staging area or index area, whatever you call it, right? So once you make changes, it's like a virtual area, virtual layer. Staging area is like a virtual layer. So once you make your changes to working directory, you have to move those changes to staging area. From staging area, you have to move them to local. This is called Git tree. It's not that from here you jump into here and then from here to here, or else from working directory to here. No, that's all not possible. right? This is the architecture of Git. This is called Git tree. This is how changes will move from working directory to staging area, from staging area to local repos. How come they are all created? I will show you everything. So just understand, whenever you want to make some changes, you will make them in a working directory, means some other directory, move them to staging area and then to local. From local to remote. What are the commands to do all of this and all, we will learn. But let me tell you, you might be having a question. Why should we move that to staging area? Is there any importance? What is the importance of this virtual layer? Yes, the importance is like this virtual layer, staging area or index area, whatever you call it, works like a preview or else pre-check before you move your changes to local. Means, let me give you, it helps you to have a better control on the changes which are moving to local. Let me give you a small example. See here in working directory, let's suppose there were 10 files you are making modifications. You want only 5 files to go to repo because only those files were ready. Others were not yet ready, work in progress. So I just want to put only 5. So you will add only these 5 to staging area. So then when you run a commit command or when you run commands, only those will be pushed to local. So to make sure you are moving right changes to local, because incomplete changes you can't push to remote, share it with others, right? It may mess up the project. So if you want to make sure of what changes going to local and if you want to have a better control, that's where the staging area helps you, right? So first you put them into staging. From staging, changes goes to local. Understood, everyone? So this is the architecture, Git tree. Move your changes from working directory to staging area, from staging to local. Now, yes, okay, let's say my configuration files were ready. I will create a remote repository and push them to remote so others can also connect and use it. Let's say in this DevOps project, I'm the lead. Let's say I made some changes. I'll create remote and push them. Now, from now onwards, my team members can pull that code and make the changes from remote. Am I clear? Understood, everyone? First, we'll get started with this use case. Okay, we'll install Git, then we'll get started with this use case. Assuming it's a new project, we'll create local repository manually, make our changes, move them from working directory, staging area, local. Then we'll take up this use case as well later.
Okay,
Uh,
Pratik,
is
yeah.
is it generally done by the developers, like making working directory, then move the code into staging, and
DevOps
then
persons also have the files, right? Configuration files, Terraform configuration files, Kubernetes manifest files.
okay, yes.
Although any files, that's what I am talking in the beginning. Anyone can use it. Nowadays, everyone is using it. This is you may consider a developer team or tester team or DevOps. This is not only specific to DevOps. Everyone have to do that. And firstly, we were learning with respect to managing our files. Then we'll talk
Yes.
about integrating it in the pipeline.
Okay.
Am I clear with this architecture? If everyone is clear with this, I would like to show you
Yes, Pratik.
another. Yeah, please.
Yeah, I'm saying like clear. Yeah.
Okay, yeah. So I would like to talk about another interesting part here. See, I was saying these are all different directories, right? Here, let me tell you an interesting part. This local repository, working directory, are physically one and the same folder. It is physically one and the same directory or same folder. How come if it is one and the same folder, then how come you are moving changes from working directory to local and all, right? See, physically it's same, but logically they are different. How it is? Let me tell you. Let's suppose, okay, I have created local repository manually and empty repository. Now, I have just created a file here, right? So if you have just created a file, that's it. I have just placed some file, copied some file into this local repository. Then that particular file is said to be in the working directory, right? Then after creating the file, if you have run this command on this file, then it is said to be in the staging area, right? Then the say physically, if you say the file is in the same folder, After adding it in the same staging area, if you run this git commit, then it will be pushed to local. Then we call that, yes, the file is in the local repository. Means physically working directory, local repository is one and the same directory, but logically this is how it is different, right? We are going to see this practically, but before seeing this practically, I just want to give you some understanding on this, right? So meaning you create a local repository means you are creating a folder, right? In that folder, your files will be version controlled by Git. And if you just place a file there and leave it, it will be called as it is in working directory. We don't say it's in local. Then if you run the command git add file name, then we say, okay, this file is in staging area. If we commit that, then we will consider like, yes, it is in the local repository.
This local repository will be on our physical machines, right? Laptop
Yes,
and okay, and
in
then
your
we can
local
put it.
machine.
Yeah, after making the changes, then we can put it on Git
We will push
remote.
those changes to remote.
Okay.
Yes. See, we remote repository, we will learn it separately. Okay, we have lot many things to do on this local first. So many things you have to learn here. So first we'll create a local repository manually, learn many things here. Then we'll push to remote and talk about remote. Maybe it may take a couple of days before we go to remote. First, we need to master this part.
Priti,
So you,
I have a question. Let's say I've created a file in working directory, and if I move that file to a staging app, so can I say that that file is tracking by the Git or means version control system? Or if I
yes.
move to the commit like local repository only, then I can say only it is tracking by the version control
Here
system.
also, from here itself, it will be tracking. But Git knows there will be files, but it says it is not tracking. But still, it knows what changes, like what files were there. From here onwards, it will be tracking.
Priti, once we will move into the remote, after that, could we change or we cannot change?
We can change definitely. Always you can change after moving to remote also.
Okay, but in anyhow, we will feel that remote is a final one, right?
Final one in the sense for that minute, for that moment, yes.
Yes. Okay.
So now we have learned about Git. Let's go and install Git. So before installing,
So,
still any questions, please?
yeah, Preeti, so once it is going to the, okay, anyway, if it is out of scope, I don't know. If we are pushing into remote, while pulling, it will come into the local repository or working directory.
Local repository. Local repository only.
It will come into the local repository, right? So to add a file from local repository to working directory, what is that?
It's not adding, right? It's removing. You are removing your changes. See, this is backward, you're saying, right? So you are removing changes from local, then it will go into staging. From them, you are removing into working directory. Yes, this is also possible. We will also see those scenarios.
No, I didn't get this. See, if any file we are pulling from Git remote repository, you told that it will be into the local repository, right? So if the file is in my local repository, I'm doing some changes.
Yeah.
So again, I need to move that file into staging area to local repository. Anyway, the file is in local repository, right?
Still, you have to add and commit. Means still those changes will be in working directory only. Like I said, you cannot directly make any changes in local. Even though your changes, whichever you pulled out in local, but the new changes you are making will be in working directory only. See, like I said, it's the same folder, right? Right? When you
Yeah, got it.
created a new file or when you are making any changes, any new changes, they'll be firstly in staging area only. Sorry, in working directory only. You have to add those changes, they move to staging, again they move to local. See, to get better clarity, first let's get with the hands-on. Once you do the hands-on, you will understand this part about modifications. I'm going to show you the modifications also. not only the new changes. Okay. So now let's get started with installing Git. Git works on multiple operating systems. Okay, Git works on Linux, Windows, Mac. So you can use any of the operating system of your choice. And Git has also got a GUI, right? Means it has got a great graphical user interface through which you can do all this push, pull, merge, everything. But if you learn this GUI initially, you will never learn the commands and the concepts. So we will not be using this Git GUI here. We'll be learning the CLI, which can be helpful at any point of time. So let's begin. Let's install Git. See, for learning it, you don't need to go for a Linux now. Okay, if you are having a laptop of Mac or a Windows, anything, you can use. This is a very lightweight tool, so you can install on your laptop very easily. Right? I'm showing you how to do that, like how to install Git. Like I'm saying, for any tool, don't save the links or download links and all, because those links may be changing always. Learn the process. Go to Google and type in download Git. Okay, you will see an official website. Always prefer the official websites for any tool. Okay, so go to gitscm.com. Here you can see the download. See, you can download it for Mac, Windows, or Linux, anything. It's up to you, right? So it was also saying GUI clients. We don't need them. So yeah, let's say it's my Windows. So I'll go to this Windows. According to the bits of your operating system, download the executable and run the exe. That's all, as simple as that, right? I believe you all people know how to download an exe and run the exe. Once you run the exe, you will be navigated through a wizard where you will be taken through the steps. It will be asking for confirmation. You have to give your confirmation and go through those steps. That's all. All this documentation is available in the Google Drive. This drive access you will get once you enroll, and whoever have enrolled might have got already access to this. So yeah, Git installation on Windows, even all those simple steps were here. Like once you start the exe, this is how it shows. Sorry, this is the wrong document. 1 minute. So this is the drive. You will get access with all the tools we were using, everything, and here is the document. Yeah. See, steps for installing it. You have all the steps. You click on this Windows, you download this executable, run the exe by clicking on next. Right? That's all you have to do. I'm not doing it again because I have Git already installed, so I can't do this again. That's why I'm showing you this. It's very simple. The installation wizard will take you through all the steps. That's it. Okay, once done, you go through all these steps by hitting next, just hit next, that's all, and keep on going, that's all. Once done, how do you open it? See here, go to the start menu, type in git bash. Okay, git bash will be installed, which will provide some bash environment to run the git commands. This is the one, right? Okay, git is installed, and you can also check the version, sorry. Right? So Git is installed. So as simple as that. Any questions in this part? Can you install this from your end? If it is Mac, go through these steps here. You have Mac, your Mac laptop, brew, install Git will do. Right? That's all. If you are having Linux system already, or else if you want to use this on Linux machines on AWS also, you can create a free account on AWS, create an instance and install. But I would suggest you don't need to go for AWS for it. I would suggest you to do it on Windows, because to AWS anyway, we will use Git on AWS also. I mean Linux instances also in some time, in coming days, in couple of days. But still, if you want to do that, you can do. Otherwise, you can use your local machine. Anything is fine. The concepts of Git, the commands remain same whether you are doing it on Windows or Linux or wherever. Right? That is about installation. Now, okay, let's suppose, okay, fine, Git is installed. I could see the version. Git is installed on my laptop. But how do I tell Git which folder in my system it has to version control? Isn't it? There were so many files, so many folders. how does Git know which folder, which file it should version control? Am I correct? Making sense? Yeah. So many folders are there. Which one it should version control? So let's suppose I want to create a separate folder where I will put all the project first. Also, I'm taking the second use case. Remember, second use case means there is nothing on remote. It's a new project. Okay, I want to develop locally, then push to remote. So there is nothing on remote. So I would like to create a separate folder or directory where I would keep all my work, all my DevOps work. So what I'll do first, create a folder, whichever you want, Git to version control. Okay, I'm creating a folder here. Let's say repo1. Okay, so this is the folder I want Git to version control. But how do you tell Git that one, like this folder you should version control? So you have to go to this folder and run a command called git init. How to go to this folder? You can do that from the CLI, right? This is the git bash CLI, okay, where you can run some git commands. Okay, first go to this folder. How do you go to this folder? Copy this address. If you are a Linux person or if you are using CMD command prompt, you know this, right? Small cd command, change directory and the path so that we will go to that directory. See here it shows you the prompt. We are in this particular directory. So meaning you have to go to the directory where you want to put all of your project work and you have to tell Git to version control that particular directory. How do you tell that? By running the command called git init in this directory. Go to the directory, whichever you want Git to version control. There run the command called git init. Git init means initialize Git, start Git. It will tell Git to version control whatever is there in this directory. Of course, now it's empty, but as you go by, when you create files, Git will be keep on version controlling them. So run git init. It says initialize empty Git repository, right? So it says yes, Git is initialized, Git is started. But how do you know? You can see here hidden files. There'll be a .git created. Go to view and see the hidden content. Select this option.
Preeti, can we change a path also in future,
Which path?
which you had copied previously?
You can create in any path.
Okay.
Yeah, like his question is like you have created
See.
a repository on desktop, and now if he wants to move it on a C drive
You
or
can.
D drive.
You can just copy and move that. I mean, copy and paste that folder or move it. Yes. See, whenever we did git init, it is creating .git. Do you see that? A hidden directory called .git. Here at the backend, you can see from the Windows Explorer or else see from the command line to see the hidden folders ls-a .git. Means whichever folder will have .git, that is nothing but a local repository. Understood? This is the point you need to make a note. How do you identify whether it is a local repository or not? That particular folder will have .git folder. It is having .git means yes, this folder is local repository. Git will be version controlling. Git will be tracking all the files here. Clear with this point, all of you?
And that will be hidden.
Hidden. That's a hidden folder. Right? If you want, you can see this. Okay, fine. I want to create some files here and I want to see how it works. Okay, let us create a file. See, you can create this way from the Explorer or else you can also do it from the CLI. CLI means you need to have little Linux basics. Those Linux basics also we will learn as a separate topic after Git. But until then, if you want, you can create this way. It's up to you how you create a file. Okay, so let's create some file here. Let's say I'm just placing it as file1.txt. I'm creating it as a text file. Okay, you may create your Java files, PHP files, HTML or some Python scripts, whatever you are comfortable, you can create simple text files also fine, because now we are learning how to version control the files. That's all. Our interest is not what is present in the file. Later on, these files will be our Terraform config files, Kubernetes manifest files, and so on, right? Because we did not create those files at You can create some dummy files and go ahead. So yes, I have created some file. Okay, let me also put some lines in this file, right? Just some dummy lines. Okay, done. I have got some file, but is Git tracking it? How does Git know whether there is a file or not? Let's see. See, do ls. ls means it will list the files. I would not have given the extension. It's okay, leave it. Okay, I would not have given the extension for text file. It's okay. So this is the file we have. But is Git tracking or not? How do you know whether Git is tracking, or else where is this file? How do you know? We already learned. Where would be this file now? It's the same directory.
Working directory.
Yeah, the directory name is repo1, same folder. Here is the file one. Yeah, but like where is it? Whether it is a working directory or staging area or local repository.
Working.
Working
You
directory.
may say that it is you created local repository repo1, but I just created the file, so it's in working directory. But how do you confirm from Git? Can you see? Let's say I'm a newbie, I don't know anything. So you run the command called git status. See, ignore this part. We'll discuss this part in branching. Now come to this part. See, Git is saying untracked file. Git is saying it's not being tracked, but still Git is tracking it. Means I would like to say here, Git knows there is a file. Okay, there is a file called file1, but Git is not tracking it. It is asking us to add the file. Means move them to staging area. It clearly says that means it is in working directory. See, whenever you are doing this, always keep this diagram in your mind. This architectural diagram should be in your mind at the bucket. You always refer this diagram and answer the questions, right? So it's in a working directory. Okay, fine. Now it's saying it's also giving you a clue. Move them to staging area so that Git can track. Okay, fine. How do you move? Git add the file name, right? So again, the file will be physical in the same folder. That's what I said. Physically, it's the same folder. See, it's still in repo1. If you have any doubt, you can also check that it's still here, right? So git add. Now I did this means where is the file? See, the message change. Initially, it was saying untracked, but now it's saying changes to be committed. To be committed means not yet committed, right? To be committed, not yet committed means where are the changes now?
Staging area.
Staging area will have uncommitted changes, unstaged changes, whatever you call it, unstaged, right? So it's saying changes to be committed. So commit them, git commit minus m flag is mandatory. M means message. This is mandatory. Git commit minus m, and then let's say file1 changes or whatever. See, this message is very important because at a later point of time, right, like after a couple of months, if you want to see what this commit is all about, like what changes happen here, you will understand by this. Means let's say created file1, some meaningful message, right? Let's suppose you created a new server in your config file with this particular code. So you put, okay, created a new file, something like that, right? Got it. So commit the changes. See, it says it was all committed. Now, if you see git status, it says nothing to commit, working tree. That's what I told you. It will be a git tree. It's all clean. Clean means, does it mean that is it deleted? See, the folder file is still there in the same, physically in the same directory. But this is how logically it's different, right? If you see ls, yes, it will list the files, ls minus a, you can see dot get and file name, right? So your file is now like whatever changes in the staging working directory were moved to staging area and then to local.
Let's see what is dot slash and double dot slash. What does
That's
that
a
mean?
path, that's all. In the Git bash is like a Linux format. It's showing the path of it.
And how do you get the path? You say pwd?
Yes. Or else initially you can also copy from here the address of the repo, copy the address, add cd, then you go to that address, go to that folder from the CLI.
And git commit has an end. So this is for the track the changes, right? The message that you will pass and
This
log.
is to commit your changes, means moving your changes to local repository. Now the changes are in local repository. Also, see, ls will list the files in the folder. Git ls files will list the files in the local repository. Now my changes were also in local, that's why it was showing that. Understood, everyone? Shall I repeat this with another file so that any other confusions, questions can be?
So Git ls files will also show the file which is present in the staging area
Yes,
or
yes.
in local repository only.
Staging area also.
Okay.
Let me repeat this with another file. Okay, I'm creating one more file here. New text file. Let's say file2. Okay, now tell me, where is this file? Not physically. Okay, physically it's in repo 1. I'm
Working
asking,
directory.
Working directory.
Working directory
right?
only, yeah.
Here, ls will show the files in the working directory. Sorry, ls will show the files in that particular folder or working directory, whatever. Now do git ls files. See, file2 is not there. Understood the difference between git ls files and ls?
Yes, yes.
Now the file is in staging, working directory. What will the status message tell us now?
One untracked file.
Untracked file. It would be
Untracked
untracked.
file. Yes, see here, untracked file 2 is being untracked, right? It's not being tracked. Okay, it will also give you clue. It is saying what to do next. Okay, I'll do git add. Now, what happens?
It will move to staging.
It will be in the staging area. If you see status, changes to be committed, it's saying to be committed means refer the architectural diagram. To be committed means it's in the staging area. Okay, fine. I want to move them to local. Then what is the command? Git commit -m message is mandatory. Without message, it will not allow. Let's say second file created. Right?
Priti, before commit, can we show Git ls files? Is there any difference we will see?
It will be
Either any
there in the, it is already there. Whenever you, it's whenever you do git add, it will be there. Initially, it
Okay.
was not there. Before adding to staging area, just created the file, but then it's not there. But after adding to staging area, yes.
Yeah, so here can't we differentiate either the files are completely committed or a few files are in staging area?
Here you can't differentiate. Only with this command you can differentiate. Git status.
Okay.
Or else there is a diff command. That command can help you differentiate. I'll show you that. Okay. So it was saying changes to be committed. Let me commit the changes. Git commit -m second file or whatever, like some comment, so that you will understand what the changes are for. Done. Now if you
So
do
after
status,
after commit, we cannot do a diff, right? Like on those two files.
diff command is just to check which changes, what are the staging changes, what are the changes in staging area, what are the changes in working directory. I'll show you those commands also. Okay, so it was showing the status. Now ls, yes, all the two files were added and committed. That's why git status is clean. So they were all in the local repository. Understood, everyone, how your changes move from working directory to staging area, from staging area to local? See, initially in the beginning, Git may be a bit tricky or confusing, but learning Git with clarity is very important. Okay, this is the basic part. When you are making some changes, right, we will be concentrating on writing the configurations on Terraform and all. It's not that someone will show you, or it's not a big task of pushing or pulling or committing. So these should be like a daily task, or else like how you open a Word document easily. That's how this you should know Git. It should not be considered as a separate technology. That's what I feel, because in day in and day out, when you are making a file, it's mandatory that you commit, you push to remote, right? That's what we do regular basis. Like how easily you open a file or how easily you submit your timesheets, that's how it should be a routine. So it's not like a separate tool you have to learn, struggle there, stuck up there. That should not happen. Means you should get confidence, you should gain expertise on Git in such a way that you just do it very easily on daily basis. So learn this thoroughly. Learning Git with clarity will gain your interest. You can play with Git if you learn the concepts properly.
So
Okay.
add is to move it to the working directory, and commit it to move it to the staging.
Add is to move it to staging area. See, I have already placed it.
Oh, okay.
Add means you move it to staging. Commit means you move it to local. Also keep this the architectural diagram, have a printout of this diagram and keep it with you, beside you always, or paste it somewhere on the wall beside you, whatever you want, however you want. But remember, you should understand this diagram and this should be printed in your mind always. Right? See here, you add, so your changes go to staging. You commit, your changes go to local. Right? Before taking up any other commands and the concept, I would like to do one more thing here. Like some of the participant is asking, or else in general, see, till now we were creating new files. What if I want to modify a file? Isn't it? It may not be always new file, it might be modification also. Correct? So here, make a point, make a note of this. See, always remember, Git works with respect to changes. What is meant by change? The change could be creating a file. Change could be deleting a file. The change could be modifying a file. Anything, everything is considered as a change, right? So for every change, the same concept follows. Means what is meant by that? Right? Change, for every change is going to be in working directory, add the change, how it works. Let's see. So to understand this, let us make a modification. Okay, let's suppose I want to modify this file. Okay, I would modify means it was an empty. I'm adding something here. That itself is a modification, right? It's not a new file. I'm just making some modification. Fine, I made some change. Now, can you tell me where is that change? Where is that modification?
In working directory.
Working directory.
Exactly, that's where this applies. Git works with respect to changes. It's not whether a new file or deletion or whatever it is. You made the change. The change will be in working directory. But like, how do you know that? Git status. See, do you see the difference? It was not saying untracked. Why it was not saying untracked? Why it was saying changes not staged. Not staged means unstaged. Unstaged changes means changes in working directory. But it will not say an untracked because it's not a new file. File is already there in the staging area. It's there in local repository, but certain modifications are there on this file, right? So it was saying changes not staged. It was asking to stage those changes. How do you stage? Here you can do it in two ways. Because it's not a new file. It's not a new file. You can add it and commit directly by, git commit -a means add and commit. This way you can do, or else you can also do separately. Git add file name, git commit. You can also do this way. Anything is fine because it's not a new file. For not new file, you can do this way or else this way. But for a new file, you have to do separately only, like this only. Means for untracked files, you have to do like this only. But if it's unstated changes, you can also do with a single command. Understood? This is not an untracked file. So I can go with a single command like this. Or else I can also do this, anything is fine. Which method should I go? Because we did this already separately, let's go with a single command. Yeah. So git commit, you can add and commit directly. -a, -m, file modified. Right, that's all. Or else you can do git add file to, then git commit. That is also fine. Done. Now if you see the status, yes, it's clean. Means now your modifications were also added and committed, but you don't see any change here. Git ls files will always show you because it was already there in the staging area. Got it? Some time back, some of the participant is asking about this, right? Let's say you got something in your local, maybe from remote, or else you have already something in local repository, right? Let's say you are making some changes. So those changes directly goes into local or from working directory to staging? Always from working directory to staging, from staging to local.
What is this -a
Huh?
represent? -a.
Add and commit. Add.
Okay.
You can add and commit in a single line. Add and commit -a and -m.
-m is like message, right?
Message flag. M for message. A for add.
Okay.
If I want to do a commit on a specific file, in this
And
folder,
louder,
two files are
please.
there, right? In this folder, there are two files, right?
Yes.
Like when you're doing a commit, is it committing the two files?
Whatever changes in the staging area will be committed. Means if
Okay.
you see this, let's see this. See, whenever you are running commit command, whatever in the staging area will be committed. Whatever in the staging area means, okay, some changes were added. Okay, like you run git add, those changes were here. All of those changes will be committed. Those changes might be on file 1, file 2, multiple changes might be having some changes, right? So all of that will be committed.
So Preeti, it means that from working to staging we can have control, but if we run the commit command, whatever it will be in staging, it all will get commit.
Correct, but still, if you want to commit a single file also, you can do.
With the files.
Git commit file name. You can also do this way.
Okay, means that also we can control.
That also you can do, like a git commit -m, the file name, like file 1, whatever, the file name and the message. Sorry, first file 1, git commit file 1 -m, some message. But generally we don't do this because whatever in the staging area will commit them. Generally, that's how we do. But still, yes, you can also do this. Right?
Can I just show the example, like make one change in file 1 and another change in file 2?
See here, to show this change, you need to commit only one, right? So make changes to both the files. Isn't it?
Yes.
Then only you will see the difference. Make the changes to both the files and then commit only one file. Like you go to file 1. Okay, making some change to file 1. So both the changes were modified. Now, if you do git status,
yeah,
okay, it will show you both of them. Let's suppose I want to add both of them, right?
so they are currently
how
in working directory, right?
those changes were in working directory, not staged means they were in the working directory. So I want to add all of them. First to staging, I want to add all of them. So what I can do git add dot. Dot means whatever in working directory, multiple files can be added, right? So done. Now if you do git status, changes to be committed, which are both of them. But if I do this, git commit -m.
Before that, can we do the diff also? Git diff.
Sorry? Diff I'll teach you separately. Diff commands I'll teach you separately with a scenario. See, I'll create a scenario and teach all of them, not just learning the command. Wait, first let's complete the scenario. Let's not club the scenarios. Okay. So git add -m if I do, like let's say files modified, both of them will be there in the local repository, right? I mean, both the modifications will go there. But if I want to commit only one file, let's say file 1. Okay, that's all. Right, let's run this. And if you do again git status, see working tree is not clean. Do you observe that? Yeah. File 2 is still there in the staging area. Otherwise, if you don't mention the file, whatever in the staging area, all of them would be committed. Got it right?
Yes.
See, you can think of many other scenarios. What if I do this? What if I commit here itself? Yeah, what happens if I commit here? Both of them will be there. You want to see that. You can check that. Try those scenarios also. Like you may be getting so many things in your mind. Try all of them. That's where the hands-on comes in the initial days. Right?
Preeti,
Initial days, do whatever we are doing in the class. Apart from that, like try your own scenarios. Yes, tell me. Yes.
Preeti, even though we have multiple files uh, unmodified, all will go to staging.
Git add dot means whatever in your working directory, like whatever changes are in working directory, all of them will be moved to staging. After moving to staging, when you run simple commit, everything in staging will go to local. But I want only one file to go to local, then give that file name. Then when you commit with that file name, only that particular file will go to local repository, not the other. See, file 2 is still there in the staging area only.
Usually, whatever we modify, those only we commit and those only will be going, right? So,
Yes.
okay.
Both of them we modified, right?
Yeah.
Here we can put both of them. It's up to you, depends on the scenario, depends on your files, your changes. It's all local repository confined to you. How you manage it, it's up to you. Right?
Yeah.
I'll show you two more commands today. See, we have done a bunch of commits till now, right? If you want to see all that commit history, we discussed, like it will show you a detailed logging. So git log will show you all the commits we have done. Means listen carefully this one, please. For each commit you make, there'll be a unique commit ID generated. It's called hash code, like a unique commit ID generated. See, including the timestamp. It was author name also it was showing dummy things because I did not put my name and all. If you want it to track, okay, you can do git config user dot name some name, again git config user dot email some email, so that will be tracked with your name, right? Do you see Monday, July, the timestamp, including the timestamp commit message, right? That's how you can see the complete log, because these were only my changes. I did not push to remote. I did not get others changes. So only my changes. When you are collaborating, when you are moving your changes remote, you will also see other changes. That's a complete detail log. If you want to see only a simple log, a brief log, git log one line. The first 6 characters, you don't need to see all the entire commit. First 6 characters are enough. Those first 6 characters and the commit message. So the brief log. This is the command to see the brief log. And again, if you want to see a particular commit, git show that commit ID. Only first 7 are enough, right? It will show you what changes happened there. The like plus hi good morning, because I have added this line. It was just showing it, right? That's how you can see each commit at a later point of time, because I don't remember, okay, what changes happen here. Some hint you can get from the commit message. If you give proper message, yes, giving proper commit messages are important, so that this is how later point of time you can understand what this commit is doing. Okay, so show command also helps you to see what role. One more thing. Suppose I want to see log of a particular file, like commit history on this particular file only. Yes, you can do. See, 2 commits happened on this file one. So you can also see log of any particular file. See, git commands are too vast. Okay, you don't need to learn all of them, because see, git log one line, git log file name, like that there will be so many sub commands. This is the main command, and there will be so many sub commands. No one remembers all of them, not required also, because we don't use all of them. But in case if you just want to try out a new thing, or else a new requirement is there, you can use a help. See, that help will show you the complete manual of it. 1 minute. Yeah, it opened in the browser. See, when I did git log help, it opened the manual in the browser this way. Right? The complete manual, git log, what it does. Name, synopsis, description, everything. Show commit logs, synopsis, description. Okay, git log, examples, options. What are all the options you have? So many options you have, you can try out. Right, like I said, we don't use them, but if you want, see, it's not possible to memorize or remember. No one is expected to memorize or remember all of that. But every command in Git, you can use this help. Manual will be opened this way, and you can see all of that there. See, any command, this is the main command, git commit help. Okay, it might have opened the page. Yeah, it opened in the same one. Yeah, see, git commit. Right? What it does, record changes to the repository, description. Okay, what are all the things you can use, right? So many flags are there. That's how you can use Git help. So Git is easy to learn, right? You can also get help this way. And for anything else, if you want to refer, this is the official documentation you can refer. Git SCM, right? Additional references. These are like additional references. And whatever commands we have done, okay, please stay back. We are not yet done. Okay, I'll give you a quiz on today's topics. I'll also show you a few things. So please stay back, not yet completed. So whatever commands we have discussed, see, we have learned some bunch of commands, right? Today's assignment was like practice all of this. All these commands, including the hands-on, will be available on the website. Like if you go to my website, yeah, lab practice Git. Yeah. See, whatever we were learning here, Git init, Git config, everything using like even explanation, description were also here available on the website. Apart from this, you also have those commands in the drive as well. I have shown you the drive today, right? There you have all the hands-on commands here as well. And the architectural diagram, the presentation also available on the drive, right? So here is how you should go through the material for hands-on. And every day hands-on is mandatory. I'm expecting you people to complete this hands-on before you join the class tomorrow, right? That is mandatory, so that we will discuss what are all the changes, like what are all the things you have done the hands-on, what issues you have faced, all of that we'll discuss. So it's important you go through the and complete your hand. Even though you are a working professional, you have experience on Git, I would suggest to do a quick walk, a kind of revision for you.
Priti,
And
ls represents?
It will list the files in that particular folder. It's actually a Linux command. It's not a Git command.
Okay. Okay.
And now please go through this quiz. Go to this page and take up quiz 1 right now. If you have meanwhile any questions, I'll stay back for 10 more minutes. I'm
Priti,
also giving this link in the Zoom chat. Please go through this quiz. Meanwhile, any other questions, anything else you have, you can answer me. Have you all got the link in the Zoom chat? Or else you can directly go to this website also and take up this quiz 1. This is related to today's topic. Few things might be there which are out of discussion today. Those will be covered tomorrow. That is to give you heads up of the topics that are coming up. Yes, any more questions?
Priti, from our working directory to staging directory, is that we are adding git add, right? And dot, it will add all the files into our stage file. If we add only specific file to staging,
It will add only that file. We did that, right? Git add file 1, give the file name. Yes, Kiran, you have to sign in with your Gmail. To take up the quiz, you have to sign in with your Gmail.